Spanning tree, minimum spanning tree, Prim's minimum spanning tree. Spanning tree. A spanning tree is a subgraph of an undirected connected graph which includes all the vertices of the graph with a minimum possible number of edges. If a vertex is missed, then it is not a spanning tree. Following are the examples of a spanning tree. On the left side we have normal graph and on the right side we have spanning tree. Now we'll talk about minimum spanning tree. A minimum spanning tree is a spanning tree in which the sum of the weight of the edges is as minimum as possible. Following are the examples. To calculate the minimum spanning tree, there are two greedy methods: Prim's minimum spanning tree and Kruskal's minimum spanning tree.
Now we'll illustrate Prim's algorithm via the following example. Let's take 3 as a starting node. Note that the highlighted vertices are the adjacent neighbors of 3. On comparing the weights of all the adjacent neighbors of 3, 8 is the minimum. Hence, the path between 3 and 5 is connected. Now compare the weights of the adjacent neighbors of 5 and 3. Here, 8 is the minimum, but since 8 is already visited, it is not considered, implies 11 is the minimum node, so the path between 5 and 7 is connected. Similarly, comparing the adjacent vertices of the visited nodes, 9 is the minimum, hence the path between 7 and 8 is connected. Now moving forward, 11 is the minimum, hence the path between 8 and 6 is connected. Now, 12 is the minimum, but on connecting the paths between 3 and 6, a cycle is formed. Hence, the link is discarded. Similarly, the connection between 7 and 3 is discarded because a cycle is formed. Next, 14 is minimum. Hence, 2 and 3 are connected. After that, the next least weight is 12. Hence, 2 is connected to 0. Now, again all the weights are compared and the minimum weight that we get that also leads to unvisited vertex is 8 and 0 is linked to 1. The next connection is formed between 1 and 4 as 9 is the minimum weight amongst all. Rest of the weights are checked which eventually leads to the formation of cycle in either of the cases and hence any of the further links are discarded. The link between 1 and 2 is discarded. The link between 4 and 5 is discarded. The link between 4 and 3 is discarded. And finally, the link between 1 and 3 is discarded.